So we've made it to the end of Chapter 6. We're going to cover two lessons with this intro video, 6.5 and 6.6. Alright, 6.5, Linear Inequalities, and 6.6, System of Inequalities. So the graph on the left, this is a linear inequality over here. You notice it looks like the regular graphs that we make. You've got your line, this line will have a slope and a y-intercept, but the new thing to notice is that you have some shading. So what these graphs will have, an inequality, remember, is your greater than, less than, greater than or equal to, less than or equal to. So instead of an equal sign, you're going to have one of those inequalities. That inequality will tell you what type of line you would draw right here. Your options would be a solid line like this one, or possibly a dotted line like you can see over on the right, and then whether or not you should shade above or below. So you'll be graphing just single inequalities like this, or you may have to graph a system of inequalities over on the right. So you've got graphing two inequalities on the same graph. You've got your solid line, dotted line, and then some region gets shaded. So the part that gets shaded, you're shading in all of your solutions to the inequality, or over here, all of your solutions to the system. And we'll talk about this more with some of the graphs. To tell whether or not something is a solution to an inequality or a system of inequalities, all you have to do is take the ordered pair they give you and plug it in and see if it works. So if we plug into the first one, y is greater than 3x, well, our y is a 0, is greater than 3 times x is 3 times 1, so the question is 0 greater than 3? And nope, that is not true. That's false. So right now, I know that that ordered pair is not a solution. Just to kind of go through the whole process, I'll go ahead and plug it in over here. Y is less than or equal to x minus 2. So you plug it into the other system also. 0 is less than or equal to 1 minus 2. 0 is less than or equal to negative 1. And that is false also. So in order for an ordered pair to be a solution, you would have to get a true statement and a true statement, and then you would say yes down here. So a solution to the system would be a point in that shaded region of the graphs we saw on the previous page. So here are steps for graphing linear inequalities. You have to solve for y if necessary so that you can graph from slope-intercept form. And then you do graph using the y-intercept and the slope, like usual. And then there's two new things we're adding into these graphs. You have to determine if the line is solid or dotted, and then you have to shade above or shade below the line. So here are our shading rules and our rules on shading above and below. So if you have a greater than symbol, so these are our greater thans, that means that you will shade above every time. That part's kind of intuitive. If something's greater than the line, shade above the line. If it's a greater than, dotted line. If it's a greater than or equal to, solid line. A nice easy way to remember that is that greater than or equal to has that extra line. So if you have that or equal to line right there, you are going to draw a solid line for your graph. Then we move on to the less than. Less than, you're going to shade below, and a less than is your solid line, your less than is your dotted line, less than or equal to solid line. Alright, so let's go through how these work. We have y is greater than 2x minus 4. So we are already solved for y, meaning we can identify our slope and our y-intercept. So the slope is 2. I'll go ahead and make it 2 over 1. The y-intercept is that negative 4. So when we graph these, we'll go ahead and start with our y-intercept at negative 4. We're going to do a slope of 2, so up 2 over 1. So this part is no different than what we've been doing. Now here comes the new part. We have to figure out what kind of line to draw. Should it be a solid or dotted line? And to determine that, all you have to do is look at the inequality. So that greater than, without the or equal to line, this is going to be a dotted line. And then where should we shade? Should we shade above or shade below? Well, every time it's greater than, you're going to shade above. So we're used to identifying the slope and y-intercept with our graphs, we want to go ahead and write these two down as well. So getting back to the graph, we said dotted line, and we're going to shade above. So a dotted line, it's kind of more like a dashed line, even though we say dotted. So it's going to look dotted line like this. And then shading above, my little trick with that is if you go to the y-intercept, so that y-intercept that we started our graph, if you have to shade above, put an arrow going above that y-intercept, and that's the side that you shade. The steeper the line gets, the trickier it is to figure out what side to shade. So that's how I start out the graphs, and I know to shade that part. So you're just going to shade in this whole region. And what we're shading in is we're shading in all the solutions to the system. So anything in that shaded region, if you were to plug in the ordered pairs to the inequality over here, you would have a true statement. All right, let's go through how to graph a system of inequalities. So now you've got two. We're going to put them on the same line. So this first one, let me go ahead and write the information over here. It's already solved for y, so our slope is -1/2. Y-intercept is 0, 1. Let's go ahead and identify the rest of the information. The inequality is a less than or equal to. So that or equal to means it's solid line. And then the less than means we're going to shade below. So we go to our graph and we start with that y-intercept 0, 1. And the slope is -1/2, so down 1 to the right 2. Up 1 to the left 2. And solid line, so go ahead and draw on your solid line. Okay, so for the shading piece, what I like to do on these is give myself little arrows to indicate where the shading will happen, and I'm going to shade at the very end of the problem. So when it says shade below, I go to the y-intercept and I draw an arrow below it, and then I'm just going to do a few more arrows below that line throughout my graph. The reason why I'm not going to shade yet is we have one more inequality to put on our graph still, and we want to see when both lines are up there, there's only one region that would be shaded. Alright, so our next one, we've got this x is less than or equal to 4. Well, we might notice that that's a special line. It's just the x without the y, so to graph it, well, first let's talk about the inequality is less than, so that's going to be a dotted line, and then shade below because of the less than. So if you come over here to your graph, you go to where x is a 4, so that's on the x-axis, over here at a 4. We said dotted line, so we'll go ahead and draw in a dotted line. Now, the tricky thing with a vertical line is you can't shade above it or below it because it's perfectly vertical. So even though I wrote down shade below, I have to think shade less than. So less than the line, if it's a vertical line, you can either shade to the right or shade to the left. And you can kind of just think about your x-axis down here and say, well, which numbers are less than 4? Those are the ones you want to shade. So right or left, we're actually going to go to the left with these. Okay, so when you figure out where to shade for your system, when two lines cross, you're going to notice you have 4 regions. You could shade this top left, this top right, or bottom left. We want to shade the region that has both sets of arrows pointing into it. And if you look at our graph, you can see that this is that region that has both the arrows from both lines pointing in. So this region, all of these ordered pairs, if you plug them into both inequalities, you'd get 2 true statements. So these are your solutions to the system. All right, sometimes we're asked to write our own inequality based off of a graph. So we start by just finding the slope and y-intercept. On this first one, we'll just zoom in and look at this one first. The y-intercept is where we cross the y-axis, so that's going to be right there. We can see that that's at 0, 1. The slope, well, let's count the rise over run. So from the point on the left to the point on the right, we're going to go up 1, 2, 3. We're going to run 1, 2, 3. So our slope is 3 over 3, but we'll go ahead and reduce that to a 1. Now, what we want is slope-intercept form for our inequality, so y equals mx plus b. The only thing is, here I'll write it like this. We know that this one is your and this one is your b. So we're going to have y, but the thing is, instead of this equal sign, we have to figure out, should it be a greater than or equal to, less than or equal to. So two things to look at to determine that. First of all, we see that it's a dotted line. So dotted lines mean we can cross off these or equal to's. It's not going to be one of those. So it's got to be either greater than or less than. And how do you tell which one it should be? You want to see where the shading is. Is the shading above or below the line? You can see that the shading is above your y-axis, so we are going to shade above, meaning greater than. So if we go back to our inequality, we're going to say y is greater than, our slope is 1x plus our y-intercept is 1. So that's the inequality we're looking for that graph. So identify the slope and y-intercept, figure out what the inequality should be, and then you're ready to write it. Alright, last one here. This is the last slide of our intro video. Let's see. Y-intercept. Well, if I look at the 2 points highlighted, neither of those is the y-intercept, but I can see that we're crossing the y-axis right there, which is at a -3. So there's our y-intercept. Slope, starting with a point on the left, we go up 1, 2, 3, 4, over 2. So our slope is 4 over 2, which reduces to a 2. Let's see. We'll go ahead and figure out our inequality options. Here are your 4 possibilities. Well, this one is a solid line, so that means it has to have the or equal to, so it can't be either of those. And then are we shading above or below? And if you go to the y-intercept, you can see that all the shading is below it, so that's going to be a less than or equal to. So our inequality, we're going to say y is less than or equal to. The slope 2 goes with the x, and then the y-intercept goes after it, -3. And that's how you write your own inequality from a graph.